Hi friends, here's your video for the order of operations in arithmetic. When it comes to this topic, lots of us remember mnemonics, little abbreviations or phrases like PEMDAS, BOMDAS, please excuse my dear Aunt Sally, or other kinds of interesting and weird phrases that help us understand that there's a certain order in which we do arithmetic or mathematical steps when we're doing calculations. I'm not going to really focus on those because it's a little bit misleading. It's attention that we could just take on the process itself. And we're thinking about really four main steps. So first, we look for grouping. If you have a little voice in your head right now telling you that parentheses is what we do first, yes, that's a grouping symbol. So parentheses is in this first category, and that's commonly a way that we illustrate or show in math that what's inside the parentheses takes priority. We want to do that arithmetic first. But parentheses aren't the only grouping symbol that we see and use. We sometimes see squared brackets. A lot of times we'll see brackets used when there are already parentheses being used somewhere in the expression, and having two sets of similar looking parentheses maybe is a little bit confusing or not as clear as we could be, so we sometimes change that second set of parentheses into square brackets. Absolute value, those vertical bars that we use to express distance from zero, or frequently we look at those and say we want the expression inside the absolute value to become a positive number. That's related to it being a distance from zero on the number line. Well, those are a type of grouping symbol also. So when we see an expression with some math inside an absolute value and then other operations going on, we prioritize what's in the absolute value, just as if it were parentheses and brackets. But then we have that additional step of making that value in the absolute value become a positive. And even fractions and roots, square roots or cube roots or different types of radicals, are also grouping symbols. There's an implied set of parentheses inside an entire root, or when you're looking at a fraction, there are implied parentheses around the numerator and separately around the denominator. So there are a lot of different types of ways to group expressions that we'll want to take care of first, and it's not necessarily going to always be parentheses. So we'll keep all of these in mind as we consider our first step in order of operations to be the grouping. Our second step in the order of operations will be to complete the exponents, the exponential expressions. Sometimes, depending on your background, this is called order, which just is a different word indicating the same thing. We're looking for these expressions where we have a base and then some superscript written small and above our usual font to express that there is a repeated multiplication. 3 with an exponent 2, or 3 to the power of 2, would be 3 times 3 to equal 9. So we do that kind of evaluation of exponential expressions before we do any other mathematical operations in the order of operations problem. Our third step is a step that is actually multiplication and division together, but we execute those operations as we work through the problem working left to right. So we don't want to think that multiply comes before divide or divide comes before multiply, because either case could be true. It depends entirely on which of those operations do we see first when we're reading the problem left to right. So let's be very clear. We're not saying that you multiply and then you divide. We're saying multiplying and dividing, let's actually write out these words, they are equal in this third step. The only thing to tell us which to do first is, again, what do we see first looking left to right? And then the same idea will apply for adding and subtracting. The one that we do first when it comes to adding and subtracting depends on what we see first reading the problem left to right. So let's get into some examples where we can break down these steps, talk about some details that we might encounter and how we handle them, and overall strategies for becoming very successful at doing these order of operations problems. And here's our first example. The quantity 6 plus 2 squared minus 5 times 3. Even the words that we use to say can express like the order. So the quantity of is kind of a phrase used to say here's something that's in parentheses. I could have maybe said after that quantity squared minus the product. That would give us another clue of like, don't think about you're about to subtract 5, but you're going to be subtracting a product, so you're going to need to multiply numbers together. I guess really the point that I'm driving at here is that we're not looking at how to make confusing problems and find a way through them, but we're really thinking more about what is the clearest way to write an expression that indicates the specific order that it should be done, because we'll see different orders can lead us to different numerical results, and we kind of want to know like which is the one true answer. With these expressions, there will be one specific number that's the correct answer, and we want to make sure that we get there consistently. So I like how the parentheses are used pretty clearly to say, in the parentheses, we're going to do this part first. After that, our knowledge of order of operations is probably going to have to kick in. So let's just go step by step. We identify the parentheses in our first step, looking at groups, the groupings. And what I like to do for an overall strategy is be very clear about what it is in the problem that I'm going to do. And the parts, the steps that I'm not doing yet, like add, subtract, multiply, I'm not there yet, I'm just going to recopy. And it's not something where you do exactly how I do it and that's how it works. It's you sort of see how I organize, you work through problems, and you figure out the organization that works for you. And what's being, what's consistently working is ultimately what you want to do. So try to keep your development of this knowledge in mind and not just to copy exactly how I do it, because I wouldn't say I've got the perfect way either. So back to the problem. Group 6 plus 2 in parentheses. So I'm going to just highlight, or underline I should say, that set of parentheses, that group. And that's what I'm going to do first. I'm actually going to be leaving that exponent out because it's not in parentheses. I'm focusing just on the group. And I see 6 plus 2 in the parentheses. If we had a lot more in the parentheses, we'd actually have to do sort of a mini order of operations problem in the parentheses. So if there was more than just the addition, I'd have to think, okay, in the parentheses, do I see exponents? Take care of those. Then multiplies and divides, working left to right. Do I see those? So with each problem, I'm actually kind of going through that checklist, but inside this set of parentheses, it's just 6 plus 2. So no exponents, check. No multiplies and divides, check. We're down to the adds and subtracts as we see them left to right. 6 plus 2 is 8. Now, with each step, if I'm ever unsure if I should recopy the parentheses, I say go ahead and do recopy the parentheses. I think it's a very helpful move. It really is difficult to go off path by using parentheses excessively. It is possible to put yourself off path by cutting parentheses loose too early. So I would say if you want to play it safe, keep parentheses in there until you have a very clear picture of the problem. So 6 plus 2, 8 in parentheses, and I will recopy everything else that I haven't touched yet, which would be that exponent 2 outside the parentheses, and then there's a subtract 5 times 3. So maybe that set of parentheses around the 8 isn't critical. Maybe I could have seen my way through the problem with just 8 without the parentheses. But I feel pretty confident about what it's asking me to do with the parentheses there. That's our next step. Now, let me pause for a moment there because we still do see parentheses. So have we really finished that first step of grouping? So when it comes to the groups, I like to ask myself, is there any math inside the group? Is there any operations, add, subtract, multiply, divide, whatever, inside that group still for me to do? Because frequently we see parentheses just around numbers, keeping things looking clear. And that's the case this time. So if I'm doing my checklist, I'm in the group, I did 6 plus 2 in the group is 8. I'm being cautious, so I have that 8 in parentheses. Now with my checklist, did I finish the group? Yes, there's nothing in the parentheses that's more math to do. It's just keeping the 8 pretty clear and this problem looking clear to me. If you're like, the parentheses make it muddier, then I would say try it. If we're working through these problems successfully, then you can keep doing what you're doing. I, through experience, know that the parentheses are helpful for me. But if they feel like a barrier for you, cut them loose and see if it's clear to you what the problem is asking for next. So the group is done. If we have parentheses, nothing to do inside. If we cut them loose, we don't even see them. Next in our checklist would be the exponents / orders. I'm just going to call them exponents. That's what my background was always calling them exponents. So 8 to the power of 2 is the next step in our order, and I'll do a sort of a highlight of that step. 8 times 8 is what we're looking at here. The base is 8, exponent is 2. That tells us you're repeatedly multiplying 8. It is a factor there 2 times, so 8 times 8, and that will give us 64. And now I'll recopy the rest. And it might seem like I'm doing a lot of recopying, but this is another strategy that I advocate for because we're doing a lot of calculations in one problem. All I need is one little mistake somewhere, and it's going to throw my answer off. So I could do like 90% of the operations in a big order of operations problem correctly, but one of them going off path wrecks the whole problem. So it's worth it for me to do the extra copying because it keeps me accurate, number one. Number two, as I recopy the problem, I can kind of ignore what I have previously done. So it's a way for me to take a problem that initially can kind of look intimidating or very cluttered, lots of business going on. And with each step, I'm able to clarify the picture, and I see this problem becoming more and more clear and feeling manageable. So another reason that it's a benefit for me to do a lot of recopying. Okay, so I've been talking a lot. I lost my place, or maybe you're working through a problem and it's been a big lift so far, and you take a breath and it's like, where was I? Or you're just interrupted by something else. Go back to the start of that list, okay? Parentheses or other groups. Do we have any? Nope. I remember I took care of that first. Okay, exponents. I took care of the exponent, and there are no exponents left. Okay, what's after exponents? Multiplying and dividing together as we see them, looking left to right. And we see some. We see 1. I have to skip right over that subtract, no matter what I'm feeling motivated to do. I see 64 minus 5, and maybe my mind is already doing that subtraction. I just have to stop because it's out of order. We have to skip the subtract or add and go to the first multiply or divide that we see going left to right. So another strategy is pay attention to what you're inclined to do, what maybe your like internal driver, your engine is saying, okay, this is what I want to do next. This is what I want to do next. And if it's not within that order of operations, that's a sign for you to head that off when you get that feeling, or just always go slow. That's something that's always in my mind with these problems. Just go slowly. If I'm rushing, that's when I go off path. Like do a subtract before I did the multiply. So go slowly, skip the subtract. I'm aware of that I might want to automatically do it, but I can't. 5 times 3 is what I'm going to do. That'll equal 15. And then some recopying. 64 and a subtract. And now it is just this subtraction problem, 64 minus 15. So let's knock this out. 64 minus 14 would take me right down to 50, and so go one more to make it not minus 14 but minus 15, or however your favorite way is of doing 64 minus 15. We want to get to this result 49. So we have evaluated. Oftentimes that's the instruction that we see with these problems. Evaluate. In that word is basically the word value. What does this all equal? What number value does it have? So all the operations we executed in the correct order, and we reached the value of 49. Can we check our answers? A check, I think, is just maybe a quick and careful run through of all the steps that we did. There's no sort of, can I take my answer and work backwards? Typically we cannot with these order of operations problems. So to do a check, I will just carefully look through my work. I see I did the grouping first. 6 plus 2 is 8. I didn't make any mistakes copying things down. Then I did do the exponent next, 8 to the second power, and that is 64. I still am accurately copying down the minus 5 times 3. My next step was multiply. Okay, so far I'm on the correct order. I did 5 times 3 to get 15. I recopied everything else accurately, so I believe that our answer does check out. So there is an example with a whole lot of narration. Let's quickly get into another example, and we'll keep it a little bit more streamlined and focus on the the actual steps and less of my commentary. And here we are. 3 times 4 minus the quantity 10 minus 6 squared, or to the power of 2. What's first? Look for the groups. We have a set of parentheses to create one group. We prioritize that. 10 minus 6 is 4. That's the only operation in that set of parentheses. I will recopy the other parts of the problem. Do a quick check to make sure I recopied everything accurately. Didn't leave anything out. 10 minus 6 does equal 4. Next. I see the parentheses, but there's no math to do inside, so our grouping step is done. Our next step is exponents. I'll box what I'm about to calculate or evaluate. 4 to the power of 2 is 16, and I'll recopy. It keeps me on path. It may feel excessive to you. Until we're really consistently, like so exceptionally rarely do we make a mistake, then it's worth it to recopy. I don't want to attach a percent to what percent correct we should be getting, but it should be, we'll do this forever, right? As long as you're doing math, you're doing order of operations as far or as wide as you go in math. So we want to be very competent at it. So we do what we have to do to do that. Okay, so I said less commentary. So parentheses and groups we did. The exponent we just did. We're down to multiplying and dividing, going left to right. And now we encounter 3 times 4, which equals 12. And we'll recopy what we have not done yet, which is the minus 16. And last is our subtract, which is good. We know our last step is adding and subtracting. So here we are, all the other operations we've done. 12 minus 16. And maybe you are in a place where you say, well, subtract, especially when I see negatives might be coming into play. We change subtracting to adding the opposite. I am definitely in favor of that. So 12 minus 16 is the same as 12 plus negative 16. To give us a result of negative 4 for the value of this expression. Okay, so far so good. Hopefully, let's work through another example together. And here we are. 2 to the third power minus the quantity 5 plus 1 squared divided by the quantity 2 times 9. Let's dive right in. We have 2 different groups. Let's do the group that we see first, working left to right. That's kind of a theme in other places, so let's stick with that theme. 5 plus 1 in a group would equal 6. I will choose to recopy everything. It is possible that I could, since that other group 2 times 9 is pretty separated from everything else, I'm not starting to intermingle things in the wrong order, so I could jump to that group and take care of that also. So I'm just going to recopy. I feel very comfortable doing a lot of recopying. I don't mind. I save up all my scratch paper, and I find free pens, so I have unlimited ink, so I don't mind the writing. It's worth it. Taking one last look at that original group 5 plus 1, which we made equal to 6. It's in parentheses still, but it's just keeping that number contained, keeping our problem organized, no further operations in the parentheses, so that group is complete. I'm not going to jump right into the exponent yet. I'm going to stay in the grouping phase and take care of our other group. 2 times 9 is 18. If I'm not sure if those parentheses will be needed, I will keep them there and recopy everything else. Now, our 2 groups are both completed. Our next step is the exponent. We have one exponent here, 6 to the power of 2. That's 6 times 6 equals 36. And a careful recopy. 2 to the third minus 36 divided by 18. If I wasn't sure about the 36, I could keep it in parentheses. It's not going to put us on the wrong path. Oh boy, what had happened? I had a blind spot for that first exponent. I did not do things in order left to right, but maybe here's an example where we can see the exponents, just like how I mentioned with the groups, when they're separate from each other, we can kind of do them in either order because they stay separate. There's no intermingling with other things yet. So we're not in a problem area. I apologize if that was way unexpected and felt like it was the wrong thing to do, what I did. It was definitely not consistent with how I've been describing things, but it isn't putting us off path. And the proof, I think, would be how this next line looks. So doing 2 to the third first would give us 8, and then the 6 squared would give us 36, but they have stayed separate. We did not jump to a different step like add or subtract or multiply yet. So I think we're still in business. We're good. Now, exponents both done. Careful recopy of the others. Now, after exponents, multiplying and dividing. So we skip the subtract so that we can take care of 36 divided by 18. You might look at this and say, do I think of this as a negative 36? It's another thing where we have some flexibility that wouldn't put us off the wrong path. My answer for now is just be very clear with what math you're doing. So if I don't look at that as a negative, I just look at it as 36, I'll make sure that I'm bringing down a negative. And if we were to incorporate that minus in with the 36, we would be left with 8 plus a negative result. So we'll get to the same place. We'll maybe find an opportunity to talk about that way of working through a problem in the near future. For now, I just blocked off 36 divided by 18, which is evenly divided to equal 2. Recopying the rest would be 8 minus that 2. And now we are at the end, 8 minus 2. You know what just happened in my mind? I thought 4. So maybe just a quick lesson, like even after all that, I don't want to let up. It's like, don't start jogging at the finish line. Well, I mean, don't run through the problem either, but don't give up your focus at the end. Yes, we've made a lot of progress, but still, one little thing putting us off path will wreck the whole answer. 6 would not equal 4, and it does need to equal 6. So maybe I will do a quick check here. Started with groups, 5 plus 1 is 6. There's our other group, 2 times 9 is 18. Everything else is being copied down correctly. 2 to the third is 8. 6 squared is 36, right? 2 to the third, that's 2 times 2 is 4 times another 2. 4 times 2 makes 8, so that's accurate. 6 times 6 is 36. We skipped the subtract to do the divide. 36 divided by 18 is 2, and 8 minus 2. So if it works, we do it. If it takes a little extra time, we do it. Extra writing, we do it. If there's a payoff, that's the only reason we need to do it. So let's take a quick little break and process. I'm going to put up 2 examples for you to try, and then we'll see how they look with a quick run through, and then move on to move on to some trickier ones. So let's look at 2 examples for you to try. So here are the 2 examples for you to try. Pause the video, work through these on paper, and then restart the video, and we'll check out the answers together. Okay, here we go. First example, starting with the group, 6 times 4 is 24, and a quick recopy. Now that group is complete, we're moving on to exponents. We have 3 to the second power, which is 9. Now we're at adds and subtracts, working from left to right. First one we see is the addition, 9 plus 24, which is 33. And finally the subtraction, 33 minus 10 equals 23. Let me do a quick check of this one. Everything's looking good. The multiply, the order, I think we're good. That was a pretty quick check on my part, but I think it's looking good. Okay, evaluated equals 23. Let's check out that next example. We're starting with a group. The product, 8 times 5 in parentheses here, which equals 40. And that does complete the group, and let's do a quick recopy. Next step, the exponent. 2 to the power of 2 is positive 4, and let's recopy. Next, we've done the group, we've done the exponent. Time for multiply and divide. As we see them going left to right, and we actually see none this time. So multiply, divide, check. Moving on to add and subtract. Remember, it's never add before subtract unless that's the order that we see them, left to right. So what do we see here working left to right? It's actually, this time it's a subtract that we see first. That's the rule. Multiplying and dividing and adding and subtracting, those two steps, we do them working left to right. I can't repeat it enough. Well, you think I could. I think I could not. 100 minus 40 is 60. I also love to recopy, so I'm going to just bring down a plus 4. And then for my last step, do this last operation addition, and 60 plus 4 equals 64. Let's do a quick check. The multiplication 8 times 5 is accurate. We did it first because it's in parentheses. Our exponent looks accurate. We copied things down correctly. I'm always focusing on my signs. It was a subtract, then an add. 100 minus 40 is 60, and definitely needed to do that first and then add second. So it looks like we have a check. Okay, now let's take it up a notch a little bit. We're going to work in some square roots. We're going to work in some divisions that are expressed as fractions. We're not going to get into a whole bunch of fractions. We're going to keep things as integers, but we're going to see expressions that show division by using a fraction. And we'll also see some less clear problems that maybe a responsible author would have used parentheses around to really make it clear what we do first. But when those parentheses aren't there, we still know what is the order that's assumed that we all do so that we all get to the same correct final answer. So that's what's coming up next. And here's the next example. Someone was typing on a keyboard that had a broken parentheses key, so they just didn't use them. So how do we make sense of this problem? Still go through our same routine, the same checklist. Any kinds of grouping, we just don't see them. So we're moving on. Exponents would be next. Use the same strategies. Be clear about what operation you're about to execute or accomplish, and do a clear copy of the parts that you haven't touched yet. Keep this problem organized. Don't go too quickly if that leads you to make errors, and be very mindful about what you're doing with each step. So we saw no parentheses, we just did the exponent. Now we're ready for multiplying and dividing. Maybe my eyes and mind are tempted by this 7 plus 2. I even see a 9 right there. So there's a part of me that's thinking, do I do that? Nope, stick to the order. Adding and subtracting comes last. We have multiplies that we need to accomplish. So skip the add. Go to the multiply. 2 times 9 is 18. And now there's another multiplication. Skip the add, skip the subtract. Go for the next multiplication. 4 times 5 is 20. Remember, at any point, we can go back to the start of that checklist to make sure we're still on the right path. So parentheses and groups we didn't have. Exponents we did that first. Multiplies and divides. We didn't have divides, just multiplies, but we did those going left to right. And so now we're at our last step, adding and subtracting, as we see it going left to right. I see first a 7 plus 18 equals 25, and then bringing down the minus 20 for our last step, 25 minus 20, and that equals 5. A quick check, exponent first. The multiplications look accurate, the recopying looks accurate, so I feel good about that answer 5. Going back to the original expression, it could have been written in a way that would have been even more clear about what operations we should be doing in what order, but even if they are not there, we still have a way that we all do operations in the same order to be able to get to the same numerical answer. So this is a place where if you are creating problems, you have the ability to give people more clues, more clarification about the order in which to do the operations. But sometimes we're not in charge of that. Sometimes we are just given problems that are not written in the clearest way, and that's when it's even more our responsibility to follow the correct order of operations. So let's put up another one similar to this, one that you can try. You'll pause the video to try it out, and then you will resume the video and we'll go through the answer together. And here it is. Added a few operations in there. No one rises to low expectations. So pause the video, see if you can apply what we've been talking about so far. Remember our order of operations. So pause the video, try it, and when you're done, come right back and we'll look at the answer. Here's how I'm seeing this problem. No groups. Okay, no commentary. Exponents. 5 squared. 5 times 5 is 25, and I will recopy. The next step would be finding the multiplies and divides working from left to right. So here's a multiply. 7 times 3 is 21. I will recopy. Still in the multiply and divide step, looking from left to right, the next one would be the 25 times 4. That's 100, and I'll quickly recopy. Now we're still in the multiply and divide step. Skip the addition, go to the division. 100 divided by 10 is 10. We're making good, careful progress. Now we're at our last step, adding and subtracting as we see them, going left to right. 21 plus 10 is up to 31. And then finally, 31 minus 1 equals 30. A quick check, but I'm feeling much more confident, comfortable with my approach. I go slowly and organized. Looks like everything is checking out well. Evaluates to equal 30. Here's our next example. We've brought some roots into the problems. Won't change too much. We know that this symbol, the radical or the root symbol, is also a kind of grouping, so there will be some prioritization there. But aside from that, let's just stick to the rhythm that we're developing. Groups first. And left to right is a good approach, so I'm going to tackle the 6 plus 3 in parentheses first. 6 plus 3 is 9. And I will just carefully recopy. I definitely feel motivated to go slowly and cautiously through this new problem. Okay, I'll keep the exponent on hold and work the other groups, the other roots in this case. So a square root of 25, that square root is asking, it's basically like the opposite of an exponent of 2. So our answer is, what number to the power of 2 would equal 25? What number times itself equals 25? And that answer is 5. And I will recopy everything else. Bear with me, I know no one likes recopying more than me. Group taken care of. One more group, and this time there's some actual arithmetic, some operations inside this last group. So let's be cautious here. And in there, order of operations still apply. Inside the radical symbol, there's an implied set of parentheses around everything in there. So in that group, we don't have exponents. We do have multiplies, a multiply. 7 times 5 is 35. I will just recopy, just focusing on what's in this group right here. Multiply first, 7 times 5 is 35. Then I'll do the add, 35 plus 1 is 36. And then we can do that square root. What number times itself equals 36? And that result is 6. So a mini problem inside. 7 times 5 plus 1, multiply first, then add, then the square root. And let's do a careful recopy. Don't want to feel like I'm going too far off path here. So there's a 9 squared, that's just carrying down, minus 5 plus, and that was what we had just worked on. This entire square root became just 6. Now we're done with that group. We're back to looking at the problem as a whole. Let's make a little more space. And if I ever feel lost, I need to be reoriented, go back to the start of that list. Parentheses and groups. Okay, I see it here, but it's just keeping things clear with that positive 6. Then exponents, I see one. 9 to the power of 2 is 81. Let me take a minute to recopy. Minus 5 plus 6. I feel like it's just a plus 6. I'm cutting those parentheses loose. And now we're up to the adds and subtracts, or down to the adds and subtracts. And we do them left to right. So first is the subtract. 81 minus 5 is 76. And then add 6 to that to get our final result, 82. So when we have a problem with radicals, we treat them as grouping symbols and accomplish any arithmetic that's inside a radical. In this case, we had a 7 times 5 plus 1 that needed its own individual attention to get it down to be a 36, and then we did the square root. We had another square root that we did early on in that grouping step. We then did an exponent, and then there were no multiplies and divides in the larger problem. We had that one in the radical. So then we got to the adds and subtracts, working left to right. A quick note that you maybe have done this problem in slightly different orders than me. And without knowing exactly what you did differently, it's hard for me to talk a whole lot about it, believe it or not. So I think I would just say that we identify what can really put us off path. So in the early stages, we do tend to have some flexibility with, oh, I could go do this exponent, or I could go work with this set of parentheses. And it's okay because they're all kind of isolated from each other. So if you did the 9 to the second power to get 81, and you've been bringing down an 81 all the time, you're like, wait, I also got to 81 minus 5 plus 6. So why didn't I go off path? So just keep an eye on that, and you'll notice that things at certain points stay isolated from each other, and until we get to like this multiply or divide or this add subtract where things start coming together. So we do have a little bit of flexibility of fuzziness. Just keep an eye on it. But generally that exists. So it's not something to really have to worry about. Why am I doing things differently and getting the same answer? Could this be a problem? It's hard to predict. Just watch what you're doing and notice when you do go off path if you can identify what caused that to happen. And definitely there are examples where a different order will still get us to the same result. But usually it's not from like, oh, I added and then went back to multiply, and then I went to a subtract, and then I went to an exponent. That generally doesn't work for any of us. So just be thoughtful about what it is that you're doing, and that your goal here is to be learning about all of this and not to just become as close to a calculator as possible. We have actual calculators that can do that. As promised, here's an example where we have a fraction that will indicate a division, an operation of division. And we're doing this example to illustrate the point that a fraction is really in the grouping category. We generally do not see them written, but in any fraction, there's really a set of parentheses grouping the numerator and a set of parentheses that's grouping the denominator. So I'll add those here so that we understand what it is that we're doing and why. And you'll understand that whenever we see a fraction, there's this kind of grouping together. We can't really jump back and forth in a fraction. We really try to develop the numerator or evaluate the numerator, then evaluate the denominator, and then see can we divide. I'm going to change my organization a little bit. I'm going to take the numerator and denominator, and I'm pulling them to the side, and they're going to get some individual work here in the corner, just so that I don't make my workspace too cluttered. So I've brought off the numerator 2 times 7 plus 11, and there's that group, and I'm doing my order. So no exponents, multiply and divide. We have 2 times 7 is 14, and then we have a plus 11 to give us our numerator 25. Okay, so up here in the numerator, I'm just going to bring down, like for my next step, there's going to be a 25 up there. Now I'll do the same with the denominator. Bring that off to the side for some individual treatment. 13 minus 2 right next to parentheses 4. I believe this is the first time we've seen this in this video. You've probably seen it before elsewhere. And it's here to remind us that a number right next to another number when it's in parentheses, and the same idea would apply if both numbers were in parentheses, that means multiply. So this 2 right to the side of the 4 in parentheses indicates it's a multiplication, 2 times 4. We're definitely doing that multiply before we do the subtract. So 2 times 4 is 8. Bringing down the 13 minus 8 to give us this result 5. 13 minus 8 is 5. So I'll bring that over for the denominator and recopy everything else. Okay, so that's how we've taken care of this fraction as part of the grouping step. So the numerator was in a group, the denominator was in a group, and we have evaluated both of those groups. So we're bringing down the rest of the problem, going back to our checklist, parentheses and other groups, they're done. Our fraction at this point, with just with a number in the numerator and a number in the denominator, is really indicating division. So that's where that part will come into play, where it will fit in. So exponents, we don't have any, thanks. After exponents, multiply and divide. So there's our division. The 25 divided by 5 does divide evenly. It equals 5. Let's do a quick recopy. Okay, groups done, exponents done, multiplies, divides, all done. Adds and subtracts, going left to right. So first is this subtract, 10 minus 5 is 5. And then we have plus 1 to give us this final answer of 6. So there's our strategy for doing fractions, putting them in the grouping category and prioritizing them up front. And within each numerator or denominator, it is a miniature order of operations problem. So we're still knowing that in this case it was do the multiplies before we do the adds or subtracts, or adds and subtracts. But basically it's our grouping, then exponents, then multiply, divide, then add, subtract. So let's put up 2 examples for you to try, where you can pause the video, try them out, and then restart the video, and we'll look through the answers together. Here we go. Pause the video, try out these problems on paper, and then come back and we'll check out the answers together. Okay, the problems look a little beefier, a little beastlier, but we'll use our same approach. We maybe just need to up our organizational game. So what do we see here? See a fraction, which means we have groups. The numerator is in a group, the denominator is in a group, then we have a square root that is also a group. So 3 separate groups, so I will choose to look at these as 3 small problems and then bring them back together into the fraction and the radical back here. So that will be the organization I'm taking on, starting with this numerator, 30 minus 4 squared plus 1. Let's cut this problem down to size. In this expression, we don't have groups. We do have an exponent. 4 to the second power is 16. I'll recopy 30 minus and then plus 1. Next, we are at adds and subtracts. We did not have any multiplies and divides again. We're working left to right. 30 minus 16 is 14. And then we are adding 1 to get a total for that numerator of 15. Now let's look at the expression that we had in our denominator. Negative 5 plus 2 to the third power. So groups none. We have, again, an exponent. 2 to the third power is 8. Let's bring down what we haven't touched yet, negative 5 plus. And now let's do this addition. Negative 5 plus 8 gives us a positive 3. So our denominator is going to be a 3. Let's go to the last group, the square root. In that radical, we have 5 squared minus 3 squared. So we'll do our exponents first. 5 squared is 25. We're skipping the subtract and coming over to the other exponent. 3 to the second power is 9. Notice I've done a little less recopying. It's just based on my confidence, my comfort as I'm going through these problems. So did the 2 exponents, but saved the subtract until this point in time. 25 minus 9 equals 16. Now be cautious, that is only what was inside of that square root this whole time. So it's a 16 in the square root, which evaluates to equal 4, because 4 times 4 equals 16. So now let's put back in what we have evaluated. In the numerator, that expression equaled 15. In the denominator, the expression equaled 3. And then the square root equaled 4. Okay, there's our new problem. Looks much more manageable. Just had to go slowly, stay organized. I don't know why I boxed it up. It's not like a final answer or anything, but it takes a little more steps. If, how do I get centered? Go to the start of the list again. Parentheses and groups. Okay, true, we have that fraction, but it's not containing any math that we need to do. Exponents, we don't have. Multiplies and divides. So we're ready to actually do the division of that fraction. 15 divided by 3, careful there, equals 5. And then we have a plus 4. And finally, that addition, 5 plus 4 equals 9. So I have my own organization here. I'd be surprised if yours looked exactly like mine, but notice that it is organizing that makes these problems much, just better for me. I stay accurate. It's a way that I can take something that feels very cluttered and cramped and break it down into more manageable pieces. I just have to work slowly, pay attention to what I'm recopying, and it makes these problems feel pretty doable. So I feel okay about working through something that looks pretty imposing. Let's go for this next example. How does it look? I don't know, not great, but it's doable. There's a group in the numerator and a group in the denominator, which has a weird appearance to me, but let's just take it one step at a time. And let's start with the numerator. I'll bring out just that expression, 4 plus 3 times 9 minus 8 times 2, and apply order of operations to this expression. Groups we don't have, exponents we don't have, so now we're looking at the multiplies and divides. We have a multiply 3 times 9 equals 27. I'm going to skip that subtract so I can come over here and do the 8 times 2 equals 16. Carefully recopying. If I broke that out into a couple different lines, I should still get to 4 plus 27 minus 16. The key is that I have not tried any adds or subtracts until all of the multiplies were completed. So at this point, we're ready for adds and subtracts, working from left to right. We have a 4 plus 27 equals 31, and bringing down minus 16, 31 minus 16 equals 15. That is our numerator. Go ahead and put that up here this time. Equals 15. Now that denominator, I'm just going to go carefully. Start with a recopy. 3 to the power of 0 minus negative 4 minus square root of 4. Thinking about the groups, we have a set of parentheses here in the middle with no math inside that we need to do. It's just containing negative 4, trying to make this problem look a little clear about what it's asking us to do. So middle parentheses, no math. Now we have a square root of 4. There's no math that we need to do inside first. It's just holding that 4, but now we can evaluate that square root of 4. We're looking for what number times itself equals 4, and that answer is 2. And let's recopy everything else. 3 to the power of 0 minus negative 4 minus, and then square root of 4 equals 2. Okay, next. Groups or parentheses we've talked about. Next would be exponents. There is an exponent, 3 to the power of 0, which is a strange one. It doesn't fit so well with the idea of like a repeated multiplication. Hopefully you've looked at exponents a little bit so you have an understanding of an exponent of 0 and why that would evaluate to equal the whole number 1. We won't break it down in this video, but any number that's not 0, if you use an exponent of 0, it equals 1. And let's recopy the rest. No more exponents, no multiplies or divides. So let's do our adds and subtracts as we see them working left to right. First we have a 1 minus negative 4. Be careful there about subtracting integers. I like to think of subtracting as adding the opposite. You maybe have other ways of what you do when you recognize minus a negative to see that as adding the positive 4. So 1 minus negative 4 is 1 plus 4, which equals 5. And now let's bring down that minus 2 and do that subtract. 5 minus 2 equals 3. Now, that was the expression for our denominator. Let's put that 3 back in the denominator and finish this problem up with the actual fraction, which is representing division. 15 divided by 3 equals 5. For this video, let's create one last example. It'll look a little involved, but it's not going to be complicated just to make a complicated problem. It's going to represent a somewhat tricky looking expression that you actually do very frequently in algebra. It's going to actually be a way that we evaluate something called the quadratic formula. So we'll do one more example. It'll incorporate the things that we've talked about so far today and actually is a model for expressions that you will see in this pattern a lot in the future if you're going in that algebra direction with your studies. So here's our last example. Has elements of things that we've developed so far in this video. We have a square root to indicate a group. We have a big fraction, which also indicates groups. We have numbers in parentheses side by side, which does mean multiplication. That often arises when we start with an algebraic expression. So like if we started with something that says, in your problem, you need to deal with negative 4ac, which is 4 times a times c. And then later on, someone says, okay, now I want you to use a negative 2 in place of a and a positive 3 in place of c. When we do that substitution, putting a number in place of an unknown variable, we like to do that in parentheses. That's a very important practice. So what we see up here is absolutely something that we would see when we start getting into algebra. And this expression as a whole is an expression that we would see when we're working with a quadratic formula. So let's begin to break it down. Like I said, our denominator is in a group, our numerator is in a group, and within that numerator we have a square root, so there's another smaller group inside that larger numerator group. And when we have groups inside of groups, or like nested groups, kind of like those nesting dolls, where you have like a doll and you open it up and it's like a miniature version of that, and then there's another one. So that's the nesting that they're talking about with these nested parentheses. We like to start with what's most on the inside, so that would be the group that's in the square root. So let's stay organized. Let's chunk this problem into smaller pieces and tackle it that way. And we'll start with the expression in the square root. Here we are. We do have sets of parentheses, but they're not containing any operations. They're just keeping numbers clear. And like I mentioned, it happens when we put numbers in place of variables. We do those in parentheses. There's a negative 5 in parentheses with the exponent outside of the parentheses to indicate it's a negative 5 times another negative 5. Negative 5 times another. So negative times negative would make a positive 25. Let's just do a little recopying. I want to make sure I'm doing this problem accurately. Not only is it like the usual order of operations problem where lots of operations, just one is going to put us off path, but when it's in a quadratic formula, usually once we get our answer, then we go and do more stuff with that answer. So it's an involved problem that's part of an even more involved problem. So if we go off path here, you're going to be doing more work with a bad number. We don't want that. So cautiously, we did the exponent. Now we are ready for multiplies and divides. So we're skipping over the subtract, 25 minus. I'm going to go right here, 4 times negative 2. And actually, there's another multiply right there. So I don't need to necessarily do that like a pair of numbers at a time. I'll get to the same place. But we can take care of all those multiplies all right now. 4 times negative 2 is negative 8. Negative 8 times 3 is negative 24. And we'll bring down the 25 and the minus. As long as we are taking care of all the multiplies before we try to do the subtract, we're good. We should get to this place right here. And now we are ready for the adds and subtracts, or in this case, just a subtract, but it's subtracting a negative. My usual strategy for subtraction is add the opposite. So this is 25 plus the opposite of negative 24, which is positive. Or however you like to see a minus negative means addition. And then the sum, 25 plus 24, is 49. Now, where did that come from? Let's be cautious and careful. That was the expression inside of the square root. That's how we got that result of 49. So I'm going to go back to our original problem and just do some recopying. In the numerator, we start with opposite of negative 5 plus square root of, and now we know inside that square root is the number 49. And then we have the denominator, 2 times negative 2. So in our original problem, we're still at the grouping step, but we took care of the square root. Now we can go for the numerator and then the denominator. You want to just take care of the denominator right now? 2 times negative 2. We can take care of that. That would equal a negative 4. Some pieces here in the numerator. I don't want to get too cluttered, so I'm just going to go to where I've got more space. Negative negative 5, or opposite of negative 5, plus square root of 49. Just grabbing that numerator to do a little evaluation of that group. We have a square root, so let's evaluate that square root of 49. What number times itself equals 49? That answer is 7. Let's recopy. Now we've got opposite of negative 5 plus 7. And you maybe are wondering, in what step do I do negative negative 5 equals a positive 5? And it could occur at different times and not put us onto the wrong path. I would say technically it's a part of the multiply step. Making a number opposite or doing negative of a number is technically multiplying it by negative 1. So it's in the multiply step where I think about it, but you maybe are noticing that you could do it sort of in, not specifically in the multiply step, and it's still working out accurately. So just keep an eye on it, make sure that what you're doing is still working. And I say technically it's part of the multiply step. So negative negative 5 would make it a positive 5, bringing down the plus 7. And then 5 plus 7 is 12. That was our expression up in the numerator, 12. Wow, it's been a challenge, but we're making some pretty good progress. We've taken this problem all the way down to one last step. We're ready to do the division that this fraction is indicating. 12 divided by negative 4. So that's going to give us a negative answer. It's going to equal negative 3. So our original expression evaluated to equal negative 3. Very interesting. This big thing, which I say is definitely a realistic expression, not complicated for the sake of being complicated, just to test our skills or see how extreme of a problem we can handle. It's actually very, very realistic. So we want to become very comfortable and confident at doing problems that have this amount of steps and these kinds of steps with negatives and positives and fractions and square roots, and that we know that we have the order of operations that we have to follow. And becoming good at these problems is important because we do it a lot. We have to evaluate expressions a lot, and it will take you some time. You'll need to practice. You'll need to actually write these problems out on paper, develop your own helpful strategies, your own system of organization, so that you can become confident, comfortable doing these problems, and get consistently accurate answers. But you've got to try it. So hopefully this video has helped. drop some questions in the comments, and we'll see if we can get more questions answered. And hopefully this has put you on a good, strong path to success with order of operations problems. Keep it real.